Hello, my name is Mr. Bakri Dasuki, physics teacher. Today our lesson is going to be for the students in level IGCSE 2. So today we're going to take 10.06 electron beams, page 238-239. So when we say electron beams, what does that mean? So the electron beams, when we have a current, it's really have the energy, the electrons will go out from this current to the near field. So the electron will try to run away from the heat. So we have here this example. You can see the drawing, page 238. You can see this is both of them. So first we're going to talk about the thermogenic emission. Thermionic emission. So the thermionic emission, it's when we have this filament in this tube. So the electrons are what they spread more in the vacuum. So this tube is empty from air. That means it has vacuum. Okay, as you can see here. So why is the vacuum not just the normal air? Because if it's the normal air, this tungsten filament, it will be what? It will be burned. Because the filament will have the gas or the air molecules and interact with them and it will melt. So it should be in vacuum. Okay? So what's happening here, we're applying a voltage on what? On this filament to warm it up. So when it's warm up, the electrons start to going to the anode. Okay? So we have cathode, or it's the filament, who send the electrons, and we have the anode. So when they send the electrons, the anode will accept them. So first, without we apply the voltage, we see here there's on the milliammeter, we don't see any current because we didn't apply the current yet. So we apply here very high voltage, it's here 400 volt. It will not, also, of course here we are applying DC supply. So when apply 400 volt for the anode and for the cathode, and we apply here 6 volt just for warming up. Okay? So what's happening here, the electrons will flowing to the anode, because of course the electrons are negative and they give this ray for the anode. It will be like a ray because of what? Again, of the high voltage. Okay? Now, moving along, here we can see how the cathode sending the electrons and the anode will accept them because it has the opposite charge. Now, moving along to the low energy lamps. So you can see here low energy lamp. Okay? So if we take this out, we'll find this circuit. We take out this circuit. We find here, as you can see, is something inside, and there's a phosphor powder inside. So actually, this circuit transfer from the AC to the DC and give what for this filament. You can see it, right? So when it's warm up inside, the electrons will go inside this, okay? And so it's ultra, so you cannot see it, ultra rays. And there's this powder is what is phosphor, so it will glow from the electrons. Okay, so it will have the same here, it will start to glow, and that's take a low energy. What inside it, for there is a poison gas Okay, it's the mercury vapor. So if you breathe this, it will be really bad, so try not to breathe it. And also the long one, the old ones. So this is an example for the low lamp batteries, as you can see, and this is its circuit. So the circuit will determine the value for the filament and for the electrons inside. Okay, so that's why you can see multiple watts for each one. Multiple watts mean multiple power. So when we increase the volt, we increase what? The light will increase the electrons. So you can look to your book, page 238. The features above are used in fluorescent tubes and compact fluorescent lamps. So it is have shown that it's CFL, CFL, CFL. Compact fluorescent lamps. Okay? Now, we take a marker, moving on to the X-ray. When you're hearing X-ray, we directly remember when we go to the doctor. I don't know if someone break a hand or something, but you go to take, say, X-ray, and you see it as a picture, and it's like very soft, right? Now they print it on computer on normal paper, but also there's the old one that is on film. So you can put to the light and see if you have a broken bone or something like this. So how it's work? It's work exactly the same way. We have here a filament, a vacuum, okay? We have the cathode and the anode. And we are applying here 10 kilovolt. It's 10,000 volt DC. That's a lot of volt. So we apply the anode and the cathode, and we apply a small voltage for keeping the what? The cathode or the filament warm. Okay? So the electrons will go so hard through the vacuum, because this filament is what is applying it high voltage for the cathode and for the anode and the cathode, and the filament is have small voltage here. Just the negative one, so it sends the electrons. So the electrons will start to go. Now here we have something that will reflect these electrons. Okay? So when it's reflected, the electrons will be out as rays. So this rays will go out here. So what actually happened to the X-ray, after this go up, here we have the body, for example, here we have my hand under this ray, and down it there's something like platform where you sit, and they put the picture, this picture I talked about, in it. So they put under it, and this will fall on your hand. Let me draw it for you. And after your hand, it will cut through. For example, we would here a hand. Okay? So, here is on the table. Here is the film. So when the rays comes, it will cut through. Of course, it's for millisecond, and it's depend on the size you take a picture. For example, your thigh is different from your arm, because your thigh will need more radiation until it gets through to the picture. Okay? So this, the X-ray, the radiation will go to the what? To the picture here, and showing us the hard density, like the bones. So in the picture, you're gonna see like this. You're gonna see what? The arm bones. here with the fingers, of course all of it bones, okay? This of course just your understanding, not a clear one. You'll find these bones on the picture. Now the rays, it's got what? The flesh and the bones and into the picture. But it shows us just the bones because they have more density than our flesh. So we're gonna see this picture, then you take it out and do process to it, and you can see your bones. Last thing we're gonna talk about is the deflection tube. So what's happening in the deflection tube is also the same thing. High voltage for the cathode and the anode. We call it electron gun because it sends the electrons. So this, from its name, deflection tube, let me write it. Deflection tube. Deflection, that means to what? Bend. So here we have the cathode and the anode, high voltage, small voltage for warming up the filament, as here and as there. Now this blade, its metal blade, have positive and negative, and also have from what? Changeable from 0 to 1000 volt. And this lamp is in vacuum also, and have fluorescent screen. Okay? So what's happening when this filament warm up and apply the high voltage, that what? The electrons will go to the anode, like here. Now because of this, the electrons, we say what? Are negative, right? So they go far from the negative and track to the positive, and it will bend. So you can control how much they will bend by applying this volt. How much volt you'll apply here. Okay? And we can also use this or curve it or deflect it by using magnet. So please look to your book, page 239. Here we have the same thing, the same metal blade, and it has what? The magnet. There is two magnets, the current coils and the magnetic field and the electron beams will change along with the magnet. So, quick review. Take the thermonic emission, how the electrons start to go from cathode to anode, how the electrons do that by applying the high voltage, we saw that. Then the X-ray, how it works, how it shows us our bonds, and we talked about this, the low energy lamps, that very useful and it's better, much better than the old lamps that take a lot of energy. Then we talked the last thing about the deflection tube, how we deflect or curve or bend the electron by two ways. Even this way we are applying voltage to this plate, the metal plate, and the fluorescent screen, and by putting two magnets, as you can see in page 239, and it also will make the electrons curve or deflect. That was our lesson for today. Thank you for good listening. Take care of yourself and don't forget to wear your mask.